Hello and welcome. In this video, we're going to be talking about how to simplify exponential expressions that are being multiplied together, or even just exponential expressions. Hello and welcome. In this video, we're going to be talking about how to simplify products of exponential expressions. So before we begin with this problem, let's take a look at a couple of background things that you should know before we start. So there are basically four rules of exponents that you'll definitely want to be aware of and that we're going to be applying to simplify the expression that we saw just a second ago. So the first one deals with what do you do when you're simplifying powers to powers. So something like x squared to the third power. Well, when we simplify powers to powers, I multiply my exponents together. So in this case, if I simplified, I would end up with x to the power of 6. Again, I get that by multiplying the two exponents that I have, so 2 times 3 gives me 6th power. The second part deals with simplifying bases with negative exponents. So here I've got x to the power of negative 2. So remember that the negative part of the exponent is basically just telling me to take the reciprocal of my base. So now the question becomes, what's the reciprocal of x? Well, think of x as just really being x over 1. So when we do the reciprocal of that, we just get 1 over x. And then once I've done the reciprocal of my base, the exponent becomes positive. So we get 1 over x to the power of positive 2. Okay, the next rule deals with multiplying like bases together. So if I have x squared times x to the third, here I would add my exponents if I wanted to consolidate this. So if I add my exponents, 2 plus 3 gives me 5. So I end up with x to the 5th. And then the last guy deals with dividing by like bases. So if I'm dividing by like bases, I'm going to subtract my exponents. So you'll notice here that I have more factors of x on the bottom than I have on the top. So when I do my subtraction, I know I'm going to be left over with factors of x on the bottom. The only question is how many. Well, if I do my subtraction, 7 minus 2 gives me 5. So I'm going to be left with 5 factors of x on the bottom. All my factors of x on the top got divided out, so all that's left there is a 1. So I'd be left here with 1 over x to the 5th. So these are the rules that I'm going to apply actually in this order to that initial problem that we looked at, this guy. So the first step that I'm going to apply is actually rule number 1. So I'm going to take care of any powers to powers by multiplying the exponents together. So you'll notice I've got this outside power here, and then if we look at the second term, well, you'll notice that I really have an exponent of 1 on the outside. It's not written there, so since it's not written, then we're to assume it's just 1. Okay, so here we go. So you'll notice the first guy that I have here is negative 3 on the inside. I've got negative 3 on the inside, and then I've got this exponent of negative 2. So I just leave negative 3 in its own little bubble. I'm not going to deal with that right now, so I'm just going to leave that as negative 3, and then I'm going to leave that exponent negative 2 outside of that bubble. Then what I'm going to do is multiply, I've got x to the 4th to the negative 2nd. So if I want to simplify that, well, I've got to multiply those exponents together. So if I do that, I end up with x to the power of negative 8. Okay, y, notice, doesn't have an exponent written there. So if it doesn't have an exponent, then that means it's just 1. So if I multiply 1 times negative 2, I get y to the negative 2nd. And then the last guy, z to the 2nd to the negative 2nd. Again, if I multiply those two guys together, I get z to the negative 4th. And then times, and now if I apply this outside exponent of 1, well, first note that x doesn't have an exponent, so I just write it in there to 1. So if I multiply 1 by 1, I just get x to the 1st. And then if I take my exponent on y, which is 2 times 1, I get 2. So I get y squared. Okay, so we've just applied that first rule of exponents. The second thing that we're going to do then is I take care of my negative exponents. So anything with a negative exponent is going to get flipped, or another way to say that again is we're taking the reciprocal of that base. So if we look back at our expression, what I want you to notice is that right now it doesn't look like we even have a fraction. So I'm going to write this as all over 1, and this guy is all over 1 as well. Then what I'm going to do is I'm just going to look at my bases that have negative exponents. So the first guy that I see that has a negative exponent is this negative 3 to the negative 2. This x to the negative 8th, the y to the negative 2nd, the z to the negative 4th, and then if I look at the second fraction, both of those guys have positive exponents, so they're just going to stay right where they're at. So when I do the reciprocal of all of the guys I just circled, well, I just end up with all of those guys going to the bottom. So negative 3 to the power of positive 2 is on the bottom now. X to the power of positive 8 is on the bottom. Y to the power of positive 2 and z to the power of positive 4 are all on the bottom because I had to take the reciprocals. Okay, what's left on the top? Well, there's something left there, and it turns out that it's just a 1. Okay, then multiplied by, the second fraction again doesn't change because both of those exponents were already positive. So I'm going to leave those two guys right where they are. So I've got x to the first, y to the second, over 1. Okay, third step. If I look back at my rules, the third step is I'm looking at multiplying stuff together. So whenever I'm multiplying like bases together, I add the exponents. Well, if we look back to the one we're doing, when I multiply these two fractions, that just means I'm multiplying my tops and I'm multiplying my bottoms. If I multiply my tops together, there are no like bases there. I'm just going to multiply 1 by x to the first, y to the second, and what that gets me is just x to the first, y to the second. Same idea on the bottom. If I multiply my bottoms together, well, I'm just multiplying that first bottom by 1. So that just gives me negative 3 squared, x to the 8th, y squared, z to the 4th. That first denominator isn't going to change because anything times 1 is just itself. Okay, fourth step. If I look back at my rules, the fourth step tells me how to divide like bases by each other. So again, what I look for is where do I have more factors of my like base, and then I subtract from there. So let's look at what we've got. So let's start with the x's. You'll notice I've got x to the first on top and x to the 8th on the bottom. Well, clearly there I have more x's on the bottom than I have on the top. So if I do my subtraction, that means 8 minus 1 gives me x to the 7th on the bottom, and all my x's on top are basically cancel out, and all I'm left with is a 1 up there. If I look at my y squared, or my y's, I've got y squared on the top and y squared on the bottom. That means all my y's are going to cancel out. So all my y's on the top are going to cancel with all my y's on the bottom, and all that's going to be left is a 1 in each place. Okay, the only other thing that I can do is, you'll notice I have this negative 3 squared. Well, I can actually multiply that out. So negative 3 squared is just negative 3 times negative 3. That's 9. So that's going to stay on the bottom. And then I'm going to write everything else. So I've got 9 and then x to the 7th. All my y's canceled times z to the 4th. If I multiply my tops together, all I'm left with there is just a 1. And that is my answer.